Assalamualaikum everyone, welcome to your favorite physics channel, College Physics. Here you will find work solutions to past papers by experienced teachers and A-star students. So please subscribe to our channel and forward it to other Cambridge learners. Thank you. Okay, we're going to start off with Paper 2, Variant 21, May-June 2021. P2 is multiple choice questions. So let's start with question number 1. The diagram shows a stone of irregular shape. Which property of the stone can be found by lowering it into a measuring cylinder half filled with water? So we have a measuring cylinder and we have a specific level of water inside. When you add the stone of an irregular shape, what happens to the water? The water level rises. जब पानी का level rise करता है तो क्या होता है? There's a change in volume of the water. Therefore, the change in volume of the water is actually equals to the volume of the stone. Because the volume of the stone plus the volume of the old water gives us the volume of the new water. I hope you guys understand that. And I'm sure you guys have studied about this before. So that's why I'm going to choose volume. A is length, for that you can use a ruler. B is mass, for that you can use a weighing machine. And the same goes for D, weighing machine. Question 2. Which row describes speed and velocity? Now, speed, as we all know, is scalar. It doesn't depend on the direction. Velocity does depend on the direction, therefore it is vector. So the answer for 2 is B. 3. 4 balls with different masses are dropped from the heights down. Air resistance may be ignored. Which ball has the smallest average speed? Now, what does speed depend on? Speed depends on the gravity. No, speed depends on the acceleration with which they're falling. So on Earth, the acceleration with which anything falls is 9.81 meters per second squared. Okay? So for every 1 meter travel, the speed increases by 9.81 ya to 10 meters per second for every 1 meter. It doesn't matter what mass it is. With all of these masses have this very same acceleration. Therefore, when they fall from different heights, the one at the highest height will have the highest or the maximum speed at the end. Because with every 1 meter, it will gain a speed of what? Of 9.81 meters per second. It doesn't matter if A is heavier than D. D will gain more speed than A because of the distance with which it has to the ground. And A की distance क्या है ground के साथ? The least amount of distance, 1 meter. Therefore, D will have the maximum average speed when it touches the ground. And when it comes to A, it will have the smallest average speed. Say? So the answer for number 3 is A. Number 4. An object of mass 2 kgs taken from the earth. Okay, it is 2 kgs on earth. Therefore, the weight on earth is weight is equals to W is equals to mg. So mass is 2 kgs and g is 10. Therefore, weight of this object on earth is 20 newtons. When the gravitational field strength is 10 newtons per kg to the moon, where the gravitational field strength is, the earth with the gravitational field strength is 10 newtons per kg to the moon, where the gravitational field is 1.6 newtons per kg. This is on the moon. That's the G for the moon. Okay? So if we write on the same formula again, this is for earth. Now let's do this for the moon. W is equals to mg. The mass remains the same. It doesn't matter which planet it's on. So 2 multiplied by g for this planet is 1.6. So the answer will be 3.2. Therefore, weight on earth is 20 and weight on moon is 3.2. So the answer is D. Number 5. Let me just erase this. Number 5. The mass of an empty flask is 34 grams. The volume of the liquid added to the flask is 20 centimeter cubed. Okay. The total mass of the flask and the liquid is 50 grams. 50 grams, therefore, okay, so the mass of the empty flask was 34 grams and the mass of the flask plus the fluid is 50 grams. Therefore, the mass of the fluid is equals to 50 minus 34. 50 minus 34 gives us 16. That is the mass of the fluid. 16 grams is the mass of the fluid. The volume of the fluid is 20 centimeter cubes. Volume of the fluid is equals to 20 centimeter cube. Therefore, the density of the fluid or the liquid is 16 upon 20. That is 0.8. And number 5 is A, 0.80 grams per centimeter cube. The extension load graph for a spring is shown. The unstretched length of the spring is 17 centimeters. When an object is suspended from the spring, the length of the spring is now 19.2 centimeters. What is the weight of the object? Take it. Now when we go from 17 to 19.2, the increase in the length, or the x, as we all know, the extension, which is x, which is the increase in length from 17 to 19.2, is 2.2. Say, and so therefore the extension is 2.2. We have 2.1, 2.2. So let me just draw a line at 2.2. This is very thick. Exactly at 2.2. Say, so what is the weight of the object? Let's go down from here. Where does it land? It lands exactly at 3. So the answer for number 6 will be 3 newtons. D. Okay. Oopsies. Question number 7. A cart has a mass of 10 kgs. A boy pushes a cart horizontally with a force of 50 newtons. The cart accelerates at 0.5 meters per second squared. What is the frictional force acting on the cart? Now, the frictional force is actually the force with which work is not done. The force might be applied on the object, but that force isn't exactly causing any work to be done. For example, we have an object, okay, and it's moving, it's on the floor, right? And you're pushing it in this direction, downwards. You are applying the force on the object, but it's not moving. So the force is frictional. Or let's just say that you're standing on a bus. You're standing on a truck. Okay, this is the back of the truck. Okay, this is the truck. There's a box on it. You're standing here and you're pushing the box. You're standing here and you're pushing the box in the left direction. However, even though you're applying a force on it, the box is not moving to the left. And the truck or the bus is moving towards the right. Therefore, the force that you are applying on the box is frictional because it's not moving in the direction. So work is not being done on the box because of this force. Therefore, this force is friction. So we're told that the boy pushes the cart with a force of 50 newtons and it accelerates at 0.5. What is the frictional force acting on the cart? इसका मतलब यही है that this entire force is not causing the acceleration. This entire force is not causing work. A part of it is causing work or causing acceleration. Now, whatever is left over, the part that's not causing work or acceleration, that will be the frictional force. So let's first find out the force that is actually being applied in order for it to accelerate or work. F is equals to ma. Mass we have 10 kgs and acceleration we have 0.5 meters per second squared, which is 5. So the actual force that is causing an acceleration or causing work is 5 newtons. So bachi kya? It's 50 minus 5 is equals to 45. This is frictional force. I'm sure the boy is applying it, but it's not really causing an acceleration. So the answer for number 7 is D. Now, number 8. The ball has a mass of 2 kgs. The ball approaches a wall at the speed of 3 meters per second and rebounds at a speed of 1 meters per second. What is the impulse on the wall? Now, as you all know, the formula of impulse is equals to force into time, which is equals to change in momentum. Now change in momentum is impulse, which is equals to mv minus mu. So the mass is obviously going to be 2, and v is, what is v? V is I think it's going to be 1. Take it. V is equals to be 1 minus 2 again. And then the direction of 3 is different. The direction of 3 is different. For example, this is the direction towards the right hand side is usually taken as positive, and the direction towards the left hand side is usually taken as negative. And I suggest that you guys use that in your calculations because that's the way it usually works. Therefore, if we're talking about 3, the velocity for 3 is minus 3 because it's moving on the left hand side. So I'm going to go minus 3. Therefore, it will be 2 minus 6, which is equals to 2 plus 6, which is equals to 8. So the answer is 8, but we have 2. We have 8 newtons and newton seconds. It's obviously newton seconds because that's the formula of impulse. So the answer for 8 is D. Which situation involves no work being done and no energy being transferred? Okay. A car skidding to a stop on a road. Okay. A car is skidding. Just say, when you're speeding really fast and you press a brake and then it just creates that screeching sort of noise. It's skidding basically on the road to a stop on the road. Obviously, there is work being done because you're stopping it. You're applying a force in the opposite direction, or you're reducing force. So obviously work effect hoga, and energy will be transferred because the skidding causes heat energy. It causes a lot of different energy changes. B, a crane lifting a load. Of course, work is being done. The force is being pulled upwards, and the direction of movement is also upwards. So work is definitely being done. A heavy load hanging from a strong bar magnet. Now nothing is actually moving. There's no force being applied. Therefore, there's no work. And if no force is being applied, nothing is moving. Therefore, no energy is being transferred as well. So the answer for number 9 is C. D is a student dragging a big box over a rough floor. Obviously, usme work ho raha hai. Obviously. Number 10. Because the formula of work itself is force into distance, so it is being dragged, it's covering distance, and a force is being applied to it. So obviously work is happening. Number 10. A student suggests that there are several ways of transferring energy to a small stationary block of iron on a smooth table. He makes the following suggestions. Heat it, shine light on it, pass a current through it. Which suggestions are correct? Once you heat it, it's going to gain heat energy, so energy will be transferred to it. So yes, shine light on it. Obviously, photoelectrics ka jo humne padha tha, if you shine light on it, it will cause what? Photons. Photons will be gained by the iron atoms, which will cause the electrons to get excited and move to high energy orbitals. So it is obviously gaining energy. It will also become hot. This also gains energy. Pass current through it. Obviously, if you pass current through it, it will heat up, and that will also cause a transfer of energy. So the answer is, all of them are correct. So the answer for number 10 will be D. Number 11. An engine produces 240 kilojoules of energy in 2 minutes. What is the power output of the energy? Power is equals to energy upon time, or the rate of change of energy. To get our energy, we have 240 kilojoules. 1, 2, 3. And the time we have is 2 minutes, which is 2 into 60 because we need seconds. So it's going to be 2400 upon 120. So number 11, the answer is, if you remove this, it's going to be around 2, 1, 2, 3. The answer is 2 kilowatts. Okay. Number 12. A book has a mass of 400 grams. The surface of the book is in contact with the table that has the dimensions 0.1 meter by 0.2 meter. The gravitational field strength G is 10 newtons per kg. What is the pressure exerted on the book due to the table due to the book? Now pressure is equals to force upon area. Let me just write this down. Pressure is equals to force upon area. Our force क्या है? Force is equals to mg. So mass we have 400 grams, which is 0.4 kgs, multiplied by F is equals to ma. So mass is 0.4 kgs, and A, which is acceleration of free falling. In this case, G is A, which is 10 newtons per kgs. Then we have area. Area is 0.1 multiplied by 0.2 because area is equals to length into breadth, which is equals to 0.02. So once you calculate this, the answer is going to be D, 200 newtons per meter squared. Okay. The diagram shows a mercury barometer. At which point is the pressure greater than the atmospheric pressure? So we have 4 different points for number 13. Now, this, whatever the atmospheric pressure is, it causes the mercury to move up this column, this barometer. ठीक है? तो यहाँ पर आकर, once it came to this place, the pressure that is inside here and the pressure outside is equal. Now it's asking at which point is the pressure greater than the atmospheric pressure. तो इसका आंसर क्या होगा? D. ठीक है? इसका आंसर होगा D. Number 14. The table gives... Oh, I didn't do this. इसका आंसर होगा D. It will be greater than the atmospheric pressure because जिस पूरे pressure से यहाँ पर apply हो रहा है, ठीक है? Obviously, it's a lot more than the pressure being applied outside. Because the pressure being applied outside will push this upwards, but it's not. It's not pushing this area upwards because this is obviously at a higher pressure than the outside. Number 14. The table gives information about molecules. Which row describes a gas? The force between molecules, if it's a gas, obviously the molecules are very farther apart. Therefore, the force between them is almost negligible. The distance between molecules is very far apart. So the answer for number 14 is C. Okay. Number 15. Very small pollen grains are suspended in water. A bright light shines from this side. There's a bright light. Pollen grains are in water. When looked through the microscope, small specks of lights are seen to be moving in a random, jerky manner. What are the moving specks of light? Okay, number A. Pollen grains are being hit by other pollen grains. Then, don't you think that I would have seen, you know what a jerky manner is? It's jerking. It's not like it's, okay, ये हमारे पास 2 molecules हैं. If they collide with each other and then they move in the opposite direction, that's Newtonian matter. I mean, so that's a Brownian motion, right? That's like collision and then it moves away. That's not jerky manner. Jerky manner is that we have this, it moves there, and all of a sudden it moves here. All of a sudden it moves there. This is jerky manner. Just say, for example, this is a particle. This is a particle and moves like this. This is jerky manner. It's not even touching anything. Why is it changing its direction? This pollen grain or this speck of light, obviously the speck of lights are pollen grains basically. Why is it moving in a jerky manner when nothing is hitting it? Obviously something is hitting it. That's why it's moving in a jerky manner. So let's see your options. Pollen grains are being hit by other pollen grains. No. वरना पे हमें क्या लिखा होता कि collision with pollen grains and with the walls. That we didn't see. That we saw it moving in a jerky manner. B. Pollen grains being hit by water. Yes. Because you cannot see water molecules. You cannot see water molecules. If this is moving in that direction, suddenly moves in this direction, that's because a water a water molecule hit it towards this direction, तभी ये इस direction में move हो गया, this pollen grain, which makes sense, which explains the jerky motion. ठीक है. Number 16. And obviously it's not these two options because you can't see water molecules, so it makes no sense. Number 16. Why are small gaps left between metal rails of a railway track? Obviously इसका answer यही है A. We know that the metal, this obviously says metal rails. Metal in heat expands and in cold contracts. ठीक है? Now if there were no spaces, when it expanded it would cause cracks, or it would just the train would, it would cause an issue with the moving of the train. Therefore the answer for number 16 is A. Number 17. A block of metal absorbs 2000 joules of thermal energy. The temperature of the block rises from 10 degrees to 20 degrees. The mass of the block is 2 kgs. What is the heat specific capacity of the metal? अब आपको इसका formula पता होता है, Q is equals to MC delta T. Q is equals to MC delta T. Now what do we need to find? हमें तो ढूंढना ही C है. So the equation for C will be, okay, let's just it will be C is equals to Q upon M delta T. Now Q we have 2000 joules upon mass, which will be 2 kgs, multiplied by change in temperature is equals to 20 minus 10, which is actually 10. So 10. So basically 200 upon 2, which is 100 joules per kg degrees Celsius. Okay, so answer for number 17 is B. Number 18. Which statement about boiling and evaporation is correct? A. Boiling requires a supply of thermal energy, but evaporation does not. Is that true? Yes, it is true. Let's look at the next options. Supply of thermal. Evaporation takes place at the surface of a liquid, but boiling takes place throughout the liquid. Yes, that's true. When water boils in a kettle, its temperature decreases. No, that's not true. When water evaporated, its temperature increases. Untrue. Boiling requires a supply of thermal energy, but evaporation does not. Okay, A और B एक तरीके से दोनों correct हैं, ठीक है? लेकिन let's just say कि if you give water, ठीक है, a specific amount of energy and it starts boiling, even if you cut off that thermal energy, let's just say आपने, if you put the stove on, the water is boiling, even if you turn the stove off, the water will still continue boiling for a while throughout the entire liquid. Okay, so that's not really necessary. And also the evaporation can also occur when thermal energy is being supplied. So this statement is a little wonky, so we're just going to go with B. Evaporation takes place at the surface of a liquid, but boiling takes place throughout the liquid. We're sure that this is exactly correct. This question is why it's important to read every single option before answering your question. Number 19. A metal rod is heated at X. Why does the Y of the end of the metal rod become hot? Basically, the heat transfers from X to Y. How does that happen? Let's just read our options. A. Energy is transferred from X end of the rod to Y end of the rod by the vibrations of the positive ions and by the movement of electrons. That is absolutely correct. It's a metal. Electrons move, they take the energy from one end to another, and the positive ions just vibrate. They don't move. Let's see our other options. Energy is transferred by the movement of positive ions only. Incorrect. Positive ions do not move. Vibration of positive ions only. Yes, vibration of positive ions occurs, but not only. Electrons also moves. Movements of electrons only. It is true, but not only. Anions will also move. Question 20. Two square sheets of metals P and Q are heated to the same temperature. दोनों का क्या है? They're different areas of the sheets of metal, but they're heated to the same temperature. The metal sheets are shown. P is black and Q is white. Sheet Q is emitting more radiation than P. Which statement explains this? This is number 20, right? A. Dull black surfaces are better conductors of radiation. That is true. Dull black surfaces are better emitters of radiation. That is also true, but they're both at the same temperature. Then why is it emitting more radiation? See, the surface of Q is larger than that of P. That actually makes sense. White surfaces are not better absorbers of radiation. So the answer will be C, because obviously the surface area is way larger. So radiation काफी हद तक ज़्यादा होगी. Even if, let's just say that the black surfaces, they absorb more energy. And even if, let's say they emit more radiation or whatsoever. But the area is so much larger. ठीक है, इसमें इसके 4 P's will actually fit inside of Q. So the surface area also actually makes a lot of difference. 21. A water wave passes into a region where the water travels more slowly. As it passes into the slow region, what happens to the frequency and what happens to the wavelength of the wave? We all know that when it moves, even if, for example, we're talking about light waves, when it changes medium, when it changes medium and the speed and the wavelength changes, lekin what happens to the frequency? वो तो same ही रहेगी ना. The frequency will always be same. So the frequency always remains the same. The wavelength. Now let's just, what is our formula? V is equals to F lambda. If that remains constant and the speed decreases, what happens to the wavelength? It increases. The frequency remains the same. So the answer, wavelength, if the frequency is constant and the velocity, what happens to the velocity? We're told that the velocity is, it moves into a slow region. Wave travels more slowly. So the velocity decreases, therefore the lambda or the wavelength also decreases because frequency is constant. Frequency constant है तो ये दोनों क्या हो जाएंगे? Directly proportional हो जाएंगे. So wavelength decreases, but frequency remains the same. So the answer for 21 is C. Question number 22. Light traveling at a speed of 3 into 10 to the power 8, that's obviously the speed of light and the speed of all the electromagnetic spectrum, strikes the surface of a glass block and undergoes refraction as it enters the block. The diagram shows a ray of this light before and after it enters the block. What is the speed of the light in the glass? अच्छा, तो जैसे आपको पता है कि हमारे पास रिफ्रैक्टिव इंडेक्स के 2 फार्मूलाज होते हैं. हम उन दोनों को कंबाइन करेंगे. एक होता है रिफ्रैक्टिव इंडेक्स इज इक्वल्स टू C अपॉन V. ये होती है स्पीड ऑफ लाइट इन वैक्यूम एंड स्पीड ऑफ लाइट इन मीडियम. एक हमारे पास है N इज इक्वल्स टू साइन I अपॉन साइन R. जब लाइटर मीडियम से डेंसर मीडियम में लाइट रिफ्रैक्ट हो रही होती है, which is I is equals to angle of incidence and R is equals to angle of refraction. Okay, so we're going to combine both of these equations and we're going to get sine I upon sine R is equals to C upon V, and हमें निकालना है V. So we will get V is equals to C into sine R upon sine I. So C हमारे पास क्या है? 3 into 10 to the power 8 multiplied by sine refraction का angle क्या है? 33 upon sine 55. So the answer is around 1.99 blah 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 blah. So इसका answer obviously होगा 1.99 is around 2 into 10 to the power 8. So the answer for 22 is B. Okay, 23. The diagram shows a narrow beam of light incident on a glass air boundary. Some of the light emerges among the surface of the glass. Okay. अच्छा, हमारे पास एक light incoming है, a narrow beam of light. Some of it emerges on the surface of the glass and some is reflected back into the glass. Which row is correct? Is this an example of total internal reflection? No. Partial internal reflection हो रही है because some of it is also coming on the surface, so it's not totally internal reflection. So this will be no. Okay? Now, is angle theta is the critical angle? Yes or no? Yes. Yes क्यों? तभी हमारे पास यहाँ पर surface पर refraction हो रही है. ठीक है? Surface पे emerge कर रही है because the angle of if this angle is the critical angle, it forms 90 degrees with the normal, which shows on the surface. So the answer for 23 इसका yes है and इन दोनों का no है. So the answer for 23 is A. Okay, number 24. An object is placed in front of a thin converging lens. The diagram shows the path of the two rays from the top of the object. That's 24. An image is formed on the screen to the right of the lens. How does this image compare with that of the object? अच्छा. पहले तो हम इनको carry on कर लेते हैं इन lines को, ठीक है? And let's form the image. अब obviously focal length पे भी depend करता है, but आपको नज़र आएगा, आपको पता है कि let's just say that the focal length is somewhere, I don't know, somewhere here, wherever it is. So let me just connect these two so it's easier हमारे लिए. ये दोनों आके यहाँ पर connect हो गई. तो image हमारी कहाँ बनेगी? Image हमारी यहाँ बनेगी. अब obviously image downwards के towards बनेगी. ठीक है? Let me just extend this line here. Say. तो image आपको नज़र आ रहा है कि obviously ये arrow it's larger. This arrow is larger than the object. So the image will be larger. And it's not the same way up. It is inverted. So it is larger and it is inverted. So the answer for 24 will be A. 25. A remote control vehicle is traveling on the surface of a planet. The vehicle senses an obstacle ahead. It sends a radio message to the control room from where it is being controlled. The control room is 2.4 into 10 to the power 6 kilometers away from the vehicle. The control room sends a message back to the vehicle telling it to stop. What is the minimum time that elapses between the vehicle sensing the obstacle and receiving the message back from the control room? So first, let us just plan out a scenario. We have a vehicle, take it. It is 2.4 into 10 to the power 6 kilometers away from the control room. So it sends a message 2.4 into 10 to the power 6 kilometers away to the control room. Then the control room sends a message back to the vehicle. So the total distance is around 4.8 into 10 to the power 6 kilometers. Remember, this is not our SI unit. If we're going to write this in the SI unit, तो ये हो जाएगा 4.8 into 10 to the power 9, because 10 to the power 6 multiplied by 10 to the power 3 to give meters. Now this is in meters. Now we have to tell what's the minimum time that elapses. In this entire period, what is the minimum time? Now we have the distance and we also have the speed. Speed क्या है? Speed, these are radio waves, right? The electromagnetic spectrum. So what is the speed of the entire electromagnetic spectrum? 3 into 10 to the power 8 meters per second. Time is equals to distance divided by speed. So we have 4.8 into 10 to the power 9 upon 3 into 10 to the power 8. The answer आएगा यहाँ पर 25 का 16, which is D. 26. A sound wave is traveling outwards from a loudspeaker into the surrounding air. Here are 3 statements. The air pressure is lower at a refraction compared with undisturbed air. Is that true? Yes, it's true. ठीक है, क्योंकि ये normal air है, let's just say. Now this is a sound wave. This is compression, this is rarefaction. Now you can see that the air pressure at the rarefaction is lower than the air pressure compared with undisturbed air, not normal air. 2. The density of the air is less at compression compared with undisturbed air. Honestly, this is 26. This is not true because मैंने आपको यहाँ draw करके दिखाया है कि compression में normal air या undisturbed air से ज़्यादा compressed है या ज़्यादा pressure. So this is not true. The third one. The distance from a compression to a rarefaction equals half a wavelength. Is that true? Yes, it's true. Say. Which statements about the sound wave are correct? Obviously, we had 1 and 3. So the answer is B. Hey, that rhymes. Lame, sorry. Question number 27. The sound from a loudspeaker must pass through 2 materials to reach a microphone. Okay. Which combination of materials give the shortest time for the sound to reach the microphone? अब आपको पता है कि sound कौन सी wave है हमारे पास? It's a medium wave. So it requires a higher density of medium, ठीक है, is equals to it being faster. जितनी ज़्यादा density के medium होगी उतनी ज़्यादा speed होगी sound waves की because it's a material medium wave. So air versus copper versus water, obviously copper will be the densest of all the materials. And over here we have obviously aluminum, which is a metal. So the answer for 27 will be C. 28. Diagram 1 shows a small compass needle with its poles marked. Sorry, it is not near any magnetic material. Diagram 2 shows a magnet bar with its pole marked. The compass needle is placed at point P. In which direction will the north pole of the compass needle point? ठीक है. अब obviously क्या कहते हैं यहाँ पर we have a compass. When we place this the compass needle, right? Wait, we have a small compass needle, ठीक है, and this is north and this is south. This when it's not near any magnetic materials. In diagram 1, it's not near any magnetic materials. Now if we place this here, ठीक है, if we place this here, which direction would the north pole of the compass needle point? It will point where? It will point to the right. क्यों? क्योंकि let me just draw this. We have magnetic field from north to south, right? North to south. Now if you place a magnet here, usually हम क्या बोलते हैं कि इसकी, if there was no magnet, the north pole would be up. However, since we have a magnet and north to south poles towards the right direction, so the needle will point towards the right direction too. It will move along with the magnetic field. The compass's needle always points towards the it moves in the direction of the magnetic field. And since this is the direction of the magnetic field, the answer will be B, to the right. 29. A student rubs a plastic rod with a cloth. The rod becomes positively charged. What happened to the rod? It has gained electrons? No, otherwise it would be negatively charged. It has gained protons? No. Positive charges don't move. It has lost electrons? Yes. जब negative charges lose करेगा, when it loses negative charges, the positive charges will be at a higher density. Therefore, it will be positively charged because it has lost the negative charges. It can only lose the negative charges. Okay, 30. An isolated metal sphere is positively charged. It is then brought near to another isolated metal sphere that is neutral. So we have a positively charged metal sphere and then we have a neutral metal sphere. It's brought towards the right. What happens to the charges on the neutral sphere as the positively charged sphere is brought close to it? What's going to happen? Repulsion. Repulsion is what's going to happen. So all the positive charges will move towards the right and the negative charges will come towards the left. Let's see what our options are. A. Some positive charges move to the right and some positive charges move to the left. Incorrect. Positive charges are moving to the right. Let's see B. Some positive charges move to the right and some negative charges move to the left. Is that true? That's not true. That is not true. यहाँ पर positives की density ज़्यादा हो जाएगी. Yes, the positive charges density will be higher. but the density will be higher because the negative charges move towards the left. यहाँ पर on the left side, you still have positive charges. You have positive charges everywhere. Positive charges do not move. But the negative charges from this side all moved towards the left. So yes, we do have a higher density of positive charges on the right side because the negative charges move to the left side. However, the positive charges do not ever move. It's always the negative charges moving. Wherever the negative charges move towards, the density of the positive charges reduces. And from wherever the negative charges move away, the density of the positive charges increases. I hope you guys understand that. So the answer for 30 is D. 31. Which statement about the resistance of a metal wire is correct? You all know the formula. Resistance is equals to resistivity length upon area. Let's see what options we have. A. The resistance is directly proportional to its length. Yes. And it is directly proportional to its cross-sectional area. No. Because it is indirectly proportional. Okay? You can see it in the formula. The resistance is directly proportional to its length. Yes. And inversely proportional to its cross-sectional area. Correct answer will be B. You can see that in the formula. 32. The circuit diagram shows a light-dependent resistor and LDR in a potential divider. A voltmeter is connected to the LDR. अब जो voltmeter है, it's connected in a parallel to the LDR. Which row shows the resistance of the LDR and the potential difference shown on the voltmeter at a specific light level? Now, if the light is bright, obviously the resistance of the LDR is low. That's why it's allowing it to be bright. If the resistance was high, then the light would be dim. ठीक है, तो हमारे पास दो options यहाँ सही हैं. If the light is bright, the resistance is low, or if the light is low, then the resistance is high. These two do not make sense. That if it's bright at the same time the resistance is high, it makes no sense. ठीक है. So we know that the answer is either A or C. Now the potential difference shown on the voltmeter. V is equals to IR. Current is constant. Now these two become directly proportional. So they should be the same. अब A और C में कौन सा voltage और resistance same है? C. For both of them it's high. So the answer is C. 33. 3 NAND gates are connected in a single chip as shown. The whole chip behaves as a single logic gate. What type of a logic gate does the chip act as? हमारे पास 3 NAND gates हैं. ठीक है. अब let's just use some values to get the output. Okay, so यहाँ पर मैंने truth tables add कर दी हैं just to make it easier for you guys. Now you all know that you have to memorize these values. I've just put it here for your understanding ताकि आसान नहीं हो. ठीक है. So let's just say we have 2 AND gates. ठीक है. Sorry, we have 2 NAND gates. Now let's use the values 0, 0. ठीक है. Input 1 and input 2. So 0, 0, 0, 0. The outputs would be 1, 1. Now if the outputs, if we put 1, 1 over here, the output will be 0. So whatever this logic gate is that the chip acts as, उसमें होगा हमारे पास inputs होंगे 0, 0 और output हमें देगा, ये total output देगा 0. Now let's use some other values. Let's just say कि input 1 पे हमारे पास 0 है और input 2 पे हमारे पास 1 है. ठीक है. 1, 1. 1, 1 का output क्या होता है हमारे पास? 1, 1 का output होता है 0. Now if we have a 1 and a 0 here, तो इसका output क्या होगा? Output होगा 1. So this over here will be 1. Now let's use our inputs again. If we have input of 0 and 1, we get an output of 1. So 0 and 1 gives us an output of 1. Okay. Now let's do 1, 1 for both of them. ठीक है. We have 1 and 1. Inputs will be 1, 1. Output for NAND gate 1, 1 will give us 0. So if we have 0, 0, The output is 1. Therefore, inputs 1, 1 over here give us an output of 1. Now, what does this match with? 0, 0 gives us a 0, 0, 1 gives us a 1, and 1, 1 gives us a 1. Let's see. You can all see, okay, 0, 0 gives us a 0. Obviously, ठीक है. 0, 1 gives us a 1. हाँ, but 1, 1 gives us a 0. कहाँ पर 1, 1 gives us a 1? एक तो हमारे पास AND गेट है और एक और गेट है, तो दोनों में से एक ही है. 0, 0 gives us a 0 here. It also gives us a 0 here. But 0, 1 gives us a 0 here. 0, 1 gives us a 1 here. Therefore, it is definitely the OR gate. Okay. 34. A solenoid is connected to a very sensitive ammeter. A rod is inserted into one end of the solenoid. It's inserted here towards the left. The ammeter shows that there is a very small electric current in the solenoid while the rod is moving. Which rod is being inserted? A small electric current hai. Why is it small even though the rod is moving? Why is it small? It's small because it is a magnetized steel rod. You guys should know this. When it's magnetized, what is going to happen? It's going to be a magnet. तभी तो यहाँ पर करंट प्रोड्यूस हो रहा है सोलेनॉइड में, वरना सोलेनॉइड में क्यों करंट प्रोड्यूस होता? Let any rod, if it's whether it's heated, it's uncharged, radiated, doesn't make a difference. If it's producing an electric current in a current that doesn't have a power source, it's obviously magnetized. So 34. 35. The diagram shows an electric generator with the coil in a vertical position. Take it. Which row describes the generator? Now what's going on? We have magnetic poles and we have an output. यहाँ पर कहीं भी, it's obviously a generator. It's going to generate current. That means we're turning it ourselves. We're providing physical force. We're turning it and बाहर हमारे पास electricity produce हो रही है. Which row describes the generator? First of all, we know it will be AC current. This is an AC generator. ये दिख के पता चल रहा है. Or second part, the voltage output will be 0 when either 1, the coil is horizontal or the coil is vertical. It will be when the coil is, this is what 35 now. When the coil is vertical. अब ये क्यों होगा? देखो, when the coil is horizontal, ठीक है? This is the coil, same coil. It's horizontal. This is north to south magnetic field. तो ये क्या हो रहा है? ये नीचे की तरफ फोर्स जा रही है, ठीक है, नीचे की तरफ मूव हो रहा है. So this is perpendicular. So obviously there will be a voltage, there will be EMF, and there will be a voltage at this point, right? But when it is vertical and the magnetic field is moving across, it's moving through, ठीक है? It's vertical and the magnetic field is moving through. This is the magnetic field. It's moving through the coil. But the current or the electrons inside the coil, their movement of direction is also towards the right. So the movement direction of the electrons inside the coil and the direction of the magnetic field are parallel. So यहाँ पर क्या होगा? A voltage difference will not be set. There'll be no voltage, there'll be no EMF, and no current will be produced. So the answer for 35 will be B, when the coil is vertical. Okay, 36. The diagram shows a transformer. There are 460 turns on the primary coil. Let me just write it down. 460. And there are 24 turns on the secondary coil. The primary voltage is 230 volts. What is the secondary voltage? Now, आपको पता है कि voltage is connected to the number of turns. So it is number of turns primary upon number of turns secondary is equals to voltage primary upon voltage secondary. Now this is what we have to find. So it will be voltage secondary is equals to voltage primary multiplied by number secondary and upon number primary. So voltage of primary is 240 multiplied by number of secondary is 24 upon number of primary 460. तो इसका आंसर आ रहा है around 12 volts. ठीक है, it makes sense कि 24 upon voltage of primary is, it makes sense, right? 230 upon 12 is equals to 460 upon 24. ठीक है. 37. The charge on a proton is E. It's positive E. What is the charge on an electron and what is the charge on a neutron? We all know charge on an electron is minus E. ठीक है, because अगर E proton का E है, it's obviously going to be positive because proton is positive. So for electron is going to be minus E. And neutron is going to be 0. The answer is D. 38. 4 students are asked to comment on the process of nuclear fission and the nuclear fusion. What their comments are recorded in the table. Which row is correct? Now, for fission, energy is absorbed. No. Large unstable nuclei spits. Two light nuclei join. Energy is released. This is correct. Fusion. A large unstable nucleus splits. No, that's fission. Energy is absorbed. मैं जो ना दोनों को साइड बाय साइड कंपैरिजन करती हूँ बिकॉज दे बोथ हैव टू बी करेक्ट. ठीक है. सो फिजन, या आई गेट इट कि फिजन में क्या होता है, एनर्जी रिलीज होती है. हाँ. अ लार्ज अनस्टेबल न्यूक्लियर स्प्लिट्स होता है. हाँ, ठीक है. लेकिन फ्यूजन में क्या होगा, फ्यूजन का भी इसके साथ वो करना चाहिए ना. सो अ लार्ज न्यूक्लियर स्प्लिट्स, नो, इसके साथ मैच नहीं हो रहा. एनर्जी इज अब्जॉर्ब्ड. No. Energy is, दोनों जगह वही लिखा हुआ है, energy is absorbed. No. 2 light nuclei join. Yes. So fission में we know energy is released, and in fusion 2 light nuclei join. Both of these statements are correct. ठीक है. So the answer is going to be, ये गलत नहीं है. This is actually right. नहीं, this is wrong. So 2 light nuclei join. So it's going to be D. 39. Radon. 219 and that is nucleon number or mass number, and proton number is 86. Radon decays by emitting an alpha particle. Which nuclide is formed in this decay? Now we know that radon 219 and 86, it will produce an alpha particle. Alpha particle का mass क्या होता है, 4, and इसका charge क्या होता है, 2. Basically it has 2 protons and 2 neutrons, so 4 nucleons in total. And the daughter cell will have 4 less, the mass number will be 4 less, so it will be 215, whatever it is, and 84. Now whichever one is 215 and 84, it is A. The graph shows the activity of radioactive source over a period of time. What is the half-life of the source? Now, half-life is, first we have the activity of 120 upon 0. When 120 becomes 60, time taken is 2 seconds. 60 becomes 30, time taken is 4 minutes. तो आपको ये तो पता चल गया कि हमारी half life is 2 minutes, and that's exactly what we're asked. What is the half life of the source? 2 minutes. You know how this is happening, right? 120 to turn 160, it moves on from here to here. This ends at 2, and then we have from 60 to 30, it stops at 4. So from 2 to 4 and from 0 to 2, it is 2 minutes.